In the name of God, hello everyone, welcome back to Farkhwa's website. My name is Masoud. Here I'm gonna appreciate Farkhwa's website to provide this opportunity for filming the whole curriculum of grade 11. So far we discussed 36 questions from chapter review, chapter 1. Right now we are going to discuss the rest of the questions, starting with question number 37. Let's read the question. A rocket moves upward starting from rest. You see, it says starting from rest means initial velocity becomes 0. With an acceleration of positive 29 meters per second squared, acceleration is given, so the object is accelerating, the object is speeding up, the rocket speeds up because the acceleration is positive and initial velocity is 0. The object starts from rest and it speeds up for 3.98 seconds. For this duration, the rocket speeds up. It runs out of fuel. Runs out of fuel means the second case is started. What do I mean by second case? I mean the case of deceleration. Because whenever the rocket runs out of fuel, there is no power anymore to support it, to accelerate it again. That's why running out of fuel means the deceleration is started. The object starts slowing down. At the end of 3.98 seconds. So I told you during 3.98 seconds, the rocket is speeding up. Let me draw a case for you like this. For example, there's a rocket here. Whenever you launch it, the initial velocity is 0. Initial velocity, let me erase this part. Initial velocity is 0, right? And it reaches for example, vertical height. Till here, for example, this the time interval here is 3.98 seconds. 3.98 seconds. The acceleration takes 3.98 seconds. After that, it runs out of fuel. The rocket runs out of fuel. It follows the original path, but with a slower velocity. It follows the original path, but gradually the rocket starts slowing down, like this. So here. After that, it starts slowing down until the object stops, for example. It reaches a position and eventually it stops. Right. So till here, this is the initial velocity. And for the case of acceleration, we have final velocity. You have to find this velocity. And the final velocity for the acceleration case becomes initial velocity for the deceleration case. So we have two cases. This is the case of acceleration, and this one, the red one, the case of deceleration. Right. But it says, but does not stop. How high does it rise above the ground? We look for vertical distance that is traveled by the rocket during the entire trip, not just during acceleration, during the entire trip. So this duration is the case of acceleration, right? It's the case of acceleration. And the upper part is the case of deceleration. Deceleration, right? So what shall we do? Firstly, we have to find the vertical distance that is traveled by the rocket during acceleration by this equation. Delta y1 becomes v initial delta t plus 1/2 a delta t squared. Delta y1 is equal to, you have to substitute the values. Instead of vi, we have 0, delta t is 3.98 seconds plus 1/2, acceleration is 29.4, and delta t is 3.98 squared. After you do the operation, after you calculate it, actually, you will find the fraction, this fraction 466 divided by 2. And the answer is almost gonna be 233 meters. So this is the answer. After that, you have to find the final velocity, as I told you. Final velocity actually is essential. Final velocity is essential for the case of deceleration, because without final velocity, you cannot predict how high does the rocket travel during deceleration. So simply we can say without final velocity, you cannot predict the vertical height for the case of deceleration. Right. That's why you have to find the final velocity by this equation. V final is equal to V initial plus A delta t. V final is equal to, substitute 0 instead of initial velocity, plus 29.4, this is the acceleration, delta t 3.94. And the answer is 117 meters per second. So this is the final velocity, 117 meters per second. As I told you actually during my explanation, this final velocity becomes initial velocity for the case of deceleration. Right? So for the case of deceleration, the final velocity becomes initial velocity. The final velocity for the case of acceleration, for the first case, becomes initial velocity for the second. Maybe you say, teacher, why does actually final velocity turn to initial velocity? Because the rocket starts slowing down from this value. It reaches this value, 117, and whenever it runs out of fuel, it starts slowing down from this value, from 117. Gradually, the velocity decreases and decreases till the object stops eventually. Right. So delta y number 2, delta y for the case of deceleration, I mean, when the rocket runs out of fuel, is used. Actually, delta y2 is found by this equation, vf squared minus v initial squared divided by 2a. This is the rearranging of one of the kinematic equations, right? This equation, v final squared is equal to v initial squared plus 2a delta x. This is the rearranging for this equation. So delta y number 2 is equal to 0 squared. You see? So final velocity, I told you, eventually the rocket actually stops. It stops for a while. That's why final velocity becomes 0. But initial velocity is 117. You have to square it. And in denominator, we have 2a, means 2 times 9.81. Why did we substitute a with 9.81? Because the rocket is in free fall. The rocket is considered to be a free fall object. That's why this 2a, it's not 2a, it's 2g, means 2 times 9.81. Delta y number 2 is equal to, we have a fraction, 3,689 divided by 19.62, and the answer is approximately becomes 698 meters. Teacher, are we done? No. But we are about to finish. We are very close to answer. So what's our duty right now? You have to add the vertical distances together to find the distance that is traveled by the rocket vertically. I mean, delta y total becomes delta y1 plus delta y2, 233 plus 698, and the answer is going to be 931 meters. Right. So this is the question of question 37. Let's move on to question number 38. Right. Let's discuss question 38. It says two cars travel westward. So here, from the beginning of the question, it's clear that the object moves in a negative direction. Two cars travel westward. Westward means negative direction, along a straight highway. One at a constant velocity. Let me underline constant velocity. Go over it. It has a meaning in physics. Constant velocity means there is no acceleration. Constant velocity means average velocity. Means zero acceleration. So the first car travels at 85 kilometers per hour, and the velocity is constant. So this is becomes a average velocity for the first car, V average number 1, and the other at a constant velocity of 115 kilometers per hour, and this one becomes V average number 2. So both cars move at the same rate. Both cars move at the same. Both cars move at constant velocity. But velocity for either differs. Velocity of each car differs, but each car has a constant velocity. Each car keeps the velocity constant. So driver of each car keeps the velocity constant without changing the magnitude of velocity. That's why we have no acceleration here. What do I mean by we have no acceleration? I'll explain it for you. Let's read the question. So, by means of these information, question says, assuming that both cars start at the same point. They start at the same point. How much sooner does the faster car? How much sooner? It focuses on the time interval. How much sooner does the faster car arrive at the destination 16 kilometers away? So what's our responsibility? What shall we do? Actually, we have to find the time interval that is taken by each car, and after that you subtract the smaller time interval from the larger one. We have 16 kilometers for destination. Destination is the same for either. That's why this is 16 kilometers per hour is the distance for car number 1 and number 2. But time interval, of course, differs because the first one is a slower car and the second one is faster car. The second car travels at let's say faster velocity than the first one, at a higher velocity than the first one. So given an unknown, V1 means V average number 1. I just let's say I didn't actually mention the subscript average on purpose for simplicity. So I had to write V average number 1, V average number 2, but I eliminated deliberately, actually on purpose. So V1 is equal to negative 85 kilometers per hour. V average number 2, negative 115 kilometers per hour. Delta X is negative 16 kilometers. We look for delta T. As I told you, for each car, there is its own time interval. For example, for the first car, T1 is equal to delta X over V1. Delta X is equal to negative 16. Destination is 16 kilometers away from each car. And that's why destination is the same for each car. Divided by average velocity number 1, negative 85. So negative simplifies, actually the negative, both negative cancel out each other. And the answer is approximately 0.2 hours. So we got 0.2 hours for the first car, for the slower car. It takes 0.2 hours to reach the destination. About this, the second case, the second step of the solution, you have to find the time interval that is taken by the second car. I mean T2 is equal to delta x over V2. This rule is convenient. T2 is equal to negative 16 divided by negative 115. Actually, negative simplifies the negative. They cancel out each other, and the answers approximately becomes 0.14 hours. So we are about to finish. One more step is left. Just subtract this value from the first value. Subtract the smaller one from the larger one. So delta T total is equal to T1 minus T2, 0.2 minus 0.14, and the answer is going to be 0.6 hours. This is the solution of the part A, of the first part of the question. Let's move on to another question, which is actually the same question, but actually it has another part. How far must the car travel? Let me show it to you right now. It says how far must the cars travel for the faster car to arrive 15 minutes before the slower car. Let me underline this expression, 15 minutes before. What do I mean by 15 minutes before? In mathematics, before means negative, right? It says faster car. How far? Means we look for delta x. We look for delta x. How far must the car travel for the faster car to arrive 15 minutes before the slower car? So eventually, at last, the faster car arrives 15 minutes before the slower car. I mean, the second car is faster, right? The second car is faster. That's why the second car arrives the destination 15 minutes before the first car. So you have to write the equation for delta t number 2 for the faster car. In terms of what? In terms of time interval of the first car. And I told you before means minus in negative. Before in mathematics, it means minus, right? So this equation matters. This equation is actually very important. Delta t number 2 is equal to delta t1 minus 15 minutes. Teacher, why did you use negative? Because it says the faster car arrives 15 minutes before the slower car. That's why you have to use the negative here. And if you rearrange the equation for delta t1 remains in its position. I want you to turn negative 15 minutes to the other side. So negative becomes positive. That's why delta t1 becomes delta t2 plus 0.25 hours. So where does this number come from? Because 15 minutes, actually minute is not accepted in SI. You have to convert it to hours. And hours are not actually allowed in SI, but here because majority of information is given in kilometers per hour and in hour, that's why you have to convert the minute into the hour. So 15 minutes divided by 60, right? 60 minutes, it will be what? It will be 1 over 4. 1 over 4 means 0.25 hours. That's why instead of 15 minutes, you have to write 0.25 hours. That's it. Let's move on to the solution. Solution takes 2 steps. The first step, you have to mention the, you have to mention the distance, actually that is equal. You have to mention the displacement, and it's equal for both cars. Means delta x1 is equal to delta x2. I want you to open the rule, break down the rule. Delta x1 becomes v1 delta t1, and delta x2 becomes v2 delta t2. Teacher, why did you use this rule? Why didn't you use the kinematic equations? Because actually kinematic equations do not work here. Because kinematic equations, if you remember, if you think about the title of kinematic equations, it says kinematic equations with constant acceleration. So kinematic equations are devised for what? Are devised for the case in which there's an acceleration. Kinematic equations or equations with constant acceleration are devised for, let's say, slowing down or speeding up case. So you are not allowed the kinematic equations. I mean, the previous questions, I mean, we had 4 equations, right? We had 4 equations that were used for the motion with constant acceleration. But here says objects or cars move with constant acceleration. That's why you have to write the equation for average velocity, not average velocity, not constant acceleration. So there's no acceleration. Keep in mind that kinematic equations only work in acceleration and deceleration, right? Whenever the object moves with the same rate, with constant velocity, these equations don't work. So therefore, instead of delta x1, we wrote v1 delta t1. Rather than delta x2, we wrote v2 delta t2. v1 remains as it is. Delta t1, you have to actually substitute the value of delta t1, which is equal to delta t2 plus 0.25. So we substitute delta t1 by this equation, right, is equal to v2 delta t2. v1 is given in the question and is equal to negative 85. Delta t2 plus 0.25, this bracket remains as it is equal to v2. We've already had v2 in the actual questions, any question, negative 115 multiplied by delta t2. Right, I want you to multiply this value, negative 85, by each term actually. So each term is multiplied by negative 85. That's why negative 85 becomes the coefficient of delta t2. Right, negative times positive becomes negative 85 multiplied by 0.25 hours is equal to, on the right side, negative 115 becomes the coefficient of delta t2. Right, so here negative 85 delta t2 remain as it is. 85 multiplied by 0.25 becomes 21.25 hours is equal to, on the right side we have the same thing without changing, just bring it down. Negative 21.25 hours, because they are identical terms, you have to subtract it from one another because they both are negative. That's why you have to add them up by negative sign. That's why the answer becomes negative 21.25 25 hours, right? On the right side, we have negative 115 delta T2 plus 85 delta T2. Excuse me, what did we do here? What did we do? This term, negative 85 delta T2 turns to the right side, right? Whenever you bring it to the right side, negative becomes positive. That's why we didn't do anything. We didn't subtract anything because they are not identical. My bad. I'm sorry about that. I said that they are identical. I didn't observe hour here. They are not identical. That's why you have to bring the negative 85 delta T2 from left side to the right side. It changes its sign to the positive. So negative 21.25 hours remains as it is, right? Let me draw it. So this one remains as it is on the left side. And on the right side, this term actually remains without changing. But negative 85 delta T2 actually came to the what? It came to the actually to the right side. That's why it becomes positive. So at last, the left side remains as it is. The right side, do we have actually identical terms or not? Are they identical? Could we add them up together? Yes, because delta T2, delta T2, they are identical. Just actually add the coefficient up together. And here we have negative coefficient here in front of delta T2. In front of another delta T2, we have 85. So negative 115 plus 85. You have to subtract 85 from 115, but the answer takes actually a negative sign because actually negative sign overcomes the positive, becomes negative 30 delta T2. So delta T2 becomes, can I cancel out negative with negative? Yeah, it can be. Delta T2 becomes known value 21.25 goes to the numerator, and coefficient of the variable goes down, it goes to the denominator, and the answer is 0.71 hours. That's why delta T2, this is the time interval that is taken by the faster car, 0.71 hours, right? But we have one more solution because it says, how far must the car travel? How far must the car travel? For the faster car, arrive 15 minutes before the slower car. So because we said that in the first step of the solution, delta x1 becomes delta x2. Whenever whenever you find delta x1 or delta x2, it doesn't matter because they are the same, right? The distance is the same. So whether you find delta x1 or delta x2, it's the same as you wish. But we found delta x2 because we've already found delta T2. So this one is easier. Delta x2 becomes V2 delta T2. V2, we've already actually had it, and it was negative, right? Delta T2 becomes 0.71, and the answer is negative 81.65 kilometers. And that's why I can say the answer, the last answer is 81.65 kilometers. And because delta x1 is equal to delta x2, so delta x1 becomes this value, 81.65 kilometers. That's it. So, so we have one more solution because it says, how far must the car travel? For the faster car, arrive 15 minutes before the slower car. Because delta x1 is equal to delta x2, so delta x1 becomes this value, 81.65 kilometers. That's it. So, so we have one more solution because it says, how far must the car travel? For the faster car, arrive 15 minutes before the slower car. That's it. So I'm gonna appreciate you to be with us for this video, and bye for now.